let's do a couple examples on planes. And I'll have to admit on this one, I just wrote them up, and then you can try them. And then I'll talk through them a little bit. Uh, and then there's more to practice, of course, in the book. We'll do some more problem sessions if you'd like. So on these, first question is the kind of like that typical question you get in like similar to analogous to the same type of question you get in algebra, where it says find an equation of a line that passes through 2 points. So basically on that type of equation, you're given 2 points, so you need a point, so they give you 2, and then you determine the slope between the 2 points, and then you put it in the equation form. So if we're given 3 points, that's in the plane. So we have these 3 points, A, B, and C, or whatever I call them, PQR. So if that's PQR, what do we need for a plane? So for a plane, we need a point. Well, we're given 3. And then the analogous to a slope is that normal vector. So we need to construct a normal vector that's normal to these vectors that's in the plane. So how do you figure out a vector that's perpendicular to any of these vectors? You do the cross product. So you cross PQ and R, and it doesn't matter whether the normal vector goes down. Okay, and you get the vectors in question. So that's what you do. You construct PQ, PR, and then cross them. So here's your PQ, and then you do the cross product. Okay, and then substitute into your formula. I'll give you the rest of these here. So that's what you do. Okay, so you got to have PQ or PR, PQ, and then you cross it to give you that normal vector in, like that. Okay, so that's the typical way of doing it. So that's just, kind of a standard way to look at it. This next piece here, so if I were to ask you the directions, how would you sketch that plane? Right, that's really the idea here. So how do you sketch that plane in 3D? So what you do is you set 2 variables to be 0. And then you solve for the other variable. And so basically what you get is just the intersections on the x, y, z, and then you draw in like a triangle. Even though you know it goes on forever in each direction, it's that triangle that gives you the basic form. So that's what you do here. Okay, so you set the variables to be 0, solve for the other variable, and then these are your points on the different axes, z-axis, y-axis, and x-axis. And then you plot those points, and then you just connect them like that. Okay, so that's your technique, like that. And so that's one way. It's hard to, otherwise it's difficult to draw the plane, like how does it cut through? And what we're going to get into, let's see, 13, 14, like chapter 15, is we might put like a cylinder in there. It's like what we might do in chapter 15 is we may say there's like a cylinder in here, like this, and it goes up to the plane, and we want to find the volume inside that cylinder. So it's like the circle, the sides, but the top is this plane on a diagonal. So that's the type of stuff we'll be doing in that chapter. So you need to know picture these concepts. Okay, last one. This is going to be a really brief video because, frankly, I just want you to look at them. Look at this question and just practice a bunch of problems. So here's a couple to do. I won't pull that up until we're ready here. Let's see, right about there. Okay, so this is in the book. Okay, find the parametric form of the line in which the plane intersects. So you have 2 planes, like that, and then another plane, and they intersect. So just picture, like, hold your hands up, and then those planes will intersect in a line. So you want to find that line. This is not a trivial question. So you're given these two planes, and you would not be given this information right here. So this isn't here, all of this isn't here. So that's all you're given right there. So suppose you're given that and try to answer the question. Okay. Well, you can read off the normal vectors. Okay, then this is what kind of like I'm trying to find. What am I looking for? X, so this, to determine that line, I need a direction vector and I need a point. So I need a point that's in both planes, and I need the direction vector. So this is where I want you to think about, how do you find, so you have an intersection of two planes, so picture two planes intersecting. How do you find a vector that is in a direction vector that's basically like in both planes? So think about that. And then you can write up the rest of this after you think about it. So here's so V will be perpendicular to both planes. I mean, both normal vectors. Okay, so you have two planes, and we want our vector to be perpendicular to both. So how do you guarantee a vector is perpendicular to both in one and in two? You do the cross product. So you cross both of those, and that's going to be our direction vector. Okay, so now we need to find a point P that is on both planes. So what you do is you set basically one variable to be 0 and solve for the other. So this is solving a system of equations, essentially. So you eliminate, basically you can, they're not parallel, so you can set one variable to be 0, and that'll kind of smash it into the xy plane, and you can figure out a point that's in both of those. Okay, so that's your technique, or one technique to use. And then we solve, and you get this point. So this point is now on both planes, and we found our direction vector, and you substitute into x, y, z. Okay, so I know I went through that quickly. Apologize this time. We'll do more of these questions in our problem sessions on next week.